Welcome to Think Tank, the Army Cyber Institute at West Point's podcast. At the Army Cyber Institute, we confront the Army's most critical cyber challenges. We engage across our government and with our allies to better understand how cyber is changing conflict, and reach out to academia and industry to bridge gaps and stimulate cyber research. We are here to engage you on the latest in cyber and information warfare. Good morning, everybody. I'm pleased to introduce Lieutenant Colonel Stephen Hamilton, Army Cyber Institute. He's here this morning to discuss with us his research that he's been doing in the electromagnetic contested environments. But before we get to that, I'd like to know a little bit more about him. So, sir, if you don't mind, could you tell us a little bit about yourself, your education, your career, and what you're currently working on?
Yeah, sure. So I graduated from West Point in '98 with a degree in computer science and went off to be a signal officer. After being in the Army for a while, I was interested in computers, so I ended up saying I was going to be a 53, which was before cyber. That was one of the way to get into computing. And I went to Auburn University to get a master's degree in software engineering, came back to West Point. I taught in the electrical engineering and computer science department. From there, I ended up going, that was right at the end of that time, U.S. Cyber Command was standing up. And so a group of us straight from the electrical engineering and computer science department all went PCS straight to U.S. Cyber Command. I got to really see it at a much more strategic level, and that was interesting for multiple reasons. I was really focused on the technical aspects of cyber, and this was, I got to look at policy and strategy, which was a totally different ballgame to me. When I finished there, I went back to grad school again. I went to Johns Hopkins University and got a PhD in computer science, and then that's when I got to the Army Cyber Institute.
Can you explain the research you are doing in the electromagnetic contested environments?
One of the things that we've found at the National Training Center in Fort Irwin or at Fort Polk, the OPFOR have been basically jamming the satellites part of the spectrum. So your UHF, VHF communications, getting that jammed, and how do you operate? And so what we've looked at is really we looked at the past and said, well, what did we do in the past when we didn't have satellite? What we used was HF radio. So in the high frequency spectrum, you actually bounce your signal off of the ionosphere. And the key is, first of all, you can't jam the ionosphere. It still exists. So it's a physical thing. So that's how we used to communicate. And so now we're looking at how do we leverage that again so that if we get jammed in the UHF, VHF realm, we go down to the HF and we use the ionosphere to get our signals beyond the line of sight. That's really the key here. If you do line of sight, you can use all kinds of spectrum from VHF all the way to super high frequency and even beyond that, especially we're seeing now with 5G and some really, really millimeter wave frequencies. They're great for point-to-point line of sight, but they don't work well if you're on the other side of a mountain.
I know that you guys have, like you just mentioned, going to Fort Irwin and then Fort Polk, Louisiana. Your team took a trip to Kathmandu and was working on the research that you guys have been conducting. What did you take away from that, and what did you guys learn from that experience?
Right, yeah, that was a great learning experience. We worked with the Pacific Command, I think it's called Indo-PACOM now. We worked with them because they were doing an exercise in humanitarian relief. So in Kathmandu, they had an earthquake a few years back. So that's a different scenario, but causes the same problems. Like when you have an earthquake, you lose your cell service, and their infrastructure just couldn't handle it. And so they lost a lot of comms, and they're like, how do we communicate if we need to when the infrastructure is just not there? Sometimes I even refer to HF radio as like infrastructureless long-haul communications, because you only need the two radios, the radio at the end point and the radio on both sides. You can make networks, but that's a great scenario. And so it was real interesting because we got to work with several other countries. That was Japan, Australia, it's just a multitude of countries that showed up. And they all brought their different radios, and it really became more of I would say it was more of an interoperability challenge, like trying to figure out which radios can work with each other, which different brands. And they even had the radio manufacturing or the salesman, I guess, for the different radios there and technical support people there to try to figure out how to make these radios interoperate.
Were you guys able to come up with a solution and figure out how you guys could all communicate with each other?
Partly, there was a lot of challenges, and I think one of the things that we learned, and it's something that all the HF operators from the 80s would be like, oh, this is how you do this. But this knowledge has been kind of retired out of the Army in a sense, and everything was a challenge. They started off with not giving us enough frequencies. When you use the ionosphere to propagate your signal, you have to understand the time of day because the ionosphere changes with the sun. You have to pick the right frequency for the right time of day. And if you don't have enough frequencies to choose from, you can't do that. And that was one of the first problems identified very quickly. They did resolve that pretty fast. But then the next challenge was one of the sites we were at was actually at a hotel. And a hotel gives you an advantage of being able to put your antenna up real high. But what it doesn't do, it doesn't give you the flexibility to put up a very large antenna because you have to worry about the actual building structure itself. So in some cases, I would rather be in a field, maybe with a few trees and use the trees to hoist it up, depending on the type of antenna. But also, I know that some of the countries brought commercial antennas. Some of them kind of built their own. And really, the antenna is a critical piece to propagating. And you basically build the antenna or you orient it in such a way to basically optimize where you're trying to communicate to. So if you're talking, we talk about NIVIS, which is the near vertical incident skywave, which is really not communicating real far, but communicating over an obstacle. So it may just be like 20 kilometers, but you're trying to shoot like over a mountain. So you still have to go to the ionosphere to get over it. And then but you're going up at a very steep angle and then coming back down. Well, a vertical antenna, even though it says vertical, it doesn't mean that it's good for near vertical incident skywave because really the antenna propagates perpendicular to the antenna. So you really want a horizontal antenna to do that. That was just a lot of lessons learned on how to configure the antenna to optimize the pathway to where you're trying to communicate to. And that was one of the big lessons learned that I had. And even, like I said, being a ham radio operator, this is things that ham radio operators have been doing for decades. And I literally was learning on the fly, like, oh, I kind of remember doing this. But generally in ham radio, I've always found everybody's just trying to communicate as far away as possible. So nobody's talking about how do you communicate just over the mountain. You're talking about how do you communicate with Germany or with Mexico or Cuba.
All of this research and everything that you're working on, like, can you explain the significance as it pertains to the Army and why this is extremely important that we're using some of the old techniques that we had, dusting off the cobwebs and reusing them?
There's a lot of challenges. First is, definitely, we already have a lot of these radios fielded in the Army. The PRC 150 Harris radio has been fielded to many units. And I've been out to the training center where a unit just says, oh, yeah, we're going to do HF. And then you go out there. They don't know how to set up an antenna. The radio's not even configured properly. That's not to say that was one example I remember. But there's definitely some units who do practice it, and they're way better at it. So in that case, it's more of an awareness and training. Like we just needed to go back and look at that. But the other thing is we're in a kind of a weird phase right now in the sunspot cycle. And there was one that happened, I think, in the 1800s, which was called the modern minimum, I think was the name of it. But it was basically a solar minimum where the ionosphere just was not very good for propagating signals. And I don't think radio was even invented at the time. So it's happened before, but we didn't. All they knew is they knew how to like count sunspots and things like that. Nobody's really sure that how bad it'll get. But we're in a minimum now. And what I find to be interesting is that now is even more, it's more important to really understand the techniques because if you don't get the full bounce off the ionosphere, it doesn't mean you can't communicate. It just means that you need to really focus on how you're going to do it. And the ways that a lot of people are doing it, even in ham radio right now, has been using digital mode. So computers have gotten really good over the past couple decades. Now it's like we're able to take a computer and invent new modulation schemes just using the sound card, and we can communicate over HF where voice isn't even possible. We're able to communicate digitally. That's the weird aspect that's happening right now.
Kind of mixing the new technology with the old and making the best of it.
Absolutely. That's exactly what it is. And I think Joe Taylor, who invented the FT8 protocol, that has taken off like wildfire in the ham community. Like I was actually on the radio last night. We were trying to make a voice contact, and then I was like, well, let's just go see what FT8 is doing. And you just heard 4 or 5 stations just going to town on it. And it's real surprising because normally, if you don't have, other than the digital modes, if the ionosphere is not good and you're not propagating, you just don't get on the radio. Like you don't hear anybody on there, and it's just, okay, well, I guess it's not good. And then people get on later when it gets good again. But with this new mode, you're hearing almost all the time I turn it on, and I see stations just talking back and forth.
That's actually really interesting. You keep bringing up the Ham Radio Club, and I know that you are the officer in charge of the amateur cadet radio club that's here at West Point. How have you been able to explain the research that you're doing and conducting with the cadets, and do you see them picking up any of these techniques and actually helping you with your research, or how do you think, what are some of those takeaways for them?
First off is playing with the digital modes and getting, we actually have a pretty nice radio thanks to a few donors. We have a Flex, I think it's a 6700 radio, which anybody that's into ham radio knows what this one is. It's very high-end software-defined radio. And it's real easy to do the digital modes on it, and it looks really cool too, so that always helps. But yeah, the cadets will get in there and they'll start operating. In fact, a couple years ago, it was a cadet that was a kicker for the football team, and he was in there making digital contacts like all the time. Like he just totally loved doing it. And I think one of the advantages that the cadet club has is, and I remember this as when I was a kid, ham radio, the radios themselves can be pretty expensive. And so giving them, these high-end radios that they can play with, they can learn about stuff and not have to, set up their own antenna and buy an expensive radio. And, $10,000 later, they have a station. Like we have that station here. So they can.
Cadets don't get paid that much.
Yeah, exactly. Exactly. It could get pretty pricey. But the good thing is they can operate and learn about it. And then it informs them, I think, as they go out in the Army, they can say, oh, yeah, I know how to communicate this way. This is how we did this before. And so I'm really hoping that we're going to increase awareness so that, we get the future signal officers or future cyber officers saying, okay, when it's jammed, this is part of our PACE plan. The contingency or emergency part, maybe just that's HF and that's digital, and this is how it works. I think one thing that is a challenge with HF is you don't get the bandwidth that you get off of a satellite in HF. So you really kind of also you need to focus on, and again, it's about training and understanding the spectrum. You don't get the bandwidth, and so you have to think about how do you operate when instead of sending like a big PowerPoint over a satellite to say this is my command brief, like how do you just send the necessary information? And that's been something I've been trying to raise awareness on. Like, hey, sometimes like I said, that FT8 protocol is awesome, but it's like one character a second. So that's pretty slow. But if you think of a text message, we send data all the time, very, very small snippets, and it's important. Like, okay, leaving now, or here's the grid coordinate, or just, did something. So those are the types of messages that you would do over HF. And I think having leaders that understand that, they can say, okay, the talking head on the VTC is important, and it's good to see facial expressions. But when you really need to communicate, you really need to focus on what is it that you actually need to convey to the other?
What's the most important?
Exactly.
Yeah, with the smallest amount of information being used over it.
Yeah, exactly. In cyber now, it's not like it was before. It's like, oh, I'll just put a firewall up and then I'll be protected and I'm good to go. It's like now you might as well plan for the attacks to happen. You have to plan for what happens when it does go down. Like it's just nonsense to think that you could just have this like perfect protection in it and everything's going to be fine.
Sir, I've actually been told that you're kind of like the ACI's Swiss Army knife, if you will, because you have so many skills that people just don't know about, and you bring them out of this toolbox. So I know you're the officer in charge of the Cadet Amateur Radio Club, but I also know that you're the OIC of the Cadet Brewing Club. Can you talk to us a little bit about that as well?
Yeah, so part of the American Institute of Chemical Engineers, AICE, is a club that does, it's actually probably the coolest place on West Point. In Bartlett Hall, we have a brewery down there, and next to it is also a chocolate making place too. So you have beer.
I didn't know they did chocolate too.
Yeah,
I knew about the brew.
They do. So Colonel Miller, April Miller, is in charge of the whole club, but she runs the chocolate side. So every once in a while you go down there, you smell some grain, you smell some hops, and you smell some chocolate. It's pretty amazing. They actually do research. In fact, one of the big tests they're running is like kinematics of yeast. So when yeast is fermenting beer, it moves around, and they're looking at like how it moves around, how it changes, the gravity goes down over time. So the club is actually an academic club, and they do they won a best poster, I think, last semester. They had a brewing poster at one of the chemical engineering events, and so that was actually pretty cool.
Mixing arts with engineering, I like it.
Yeah, absolutely. And then that was my point. I said, hey, I'm a computer scientist. I brew beer, but I'm not a chemist at all. So, like I said, this project I'm working on with them is they literally were going into the room, sampling the beer like once every 6 hours or 12 hours, whenever they're able to get in there, and looking at the fermentation. And of course, my mind starts racing, and I'm like, we need to automate this. And I could probably even put this on a radio and transmit it up to the radio club room and then send it out over a tweet. There's like a million things I'm thinking of. But we actually did get a tilt hydrometer, which transmits Bluetooth to an Android device, and it'll actually log the fermentation as it's happening, so you can actually see the gravity go down, which is what happens when the yeast eats the sugars. The gravity goes down, and CO2 comes out, and alcohol is created. So that's still a work in progress, but I'm hoping we can get that electrically done, because then we'll be able to do a pretty decent paper on yeast and how it goes through its journey when it's fermenting the beer.
It's really neat. Anything else you'd like to add? Any little tidbit of information we haven't already covered, or something else in that Swiss Army knife of yours?
Yeah, well, we've covered a lot. HF has been a focus of our studying right now, but we also in the Electrical Engineering Computer Science Department just conducted a cool field test of a cadet tracker system. So again, what do you do when satellites aren't available? In their case, they got a grant to just take a look at how to track cadets during land nav. They were using like some kind of an Iridium. I think this summer they're still using an Iridium or some kind of satellite-based tracking device, which is kind of expensive. They looked at the same thing, like how else could we track? And I recommended years ago, I said, APRS is the Automatic Packet Reporting System, invented by Bob Bernunga, who's down at the Naval Academy. This system is used by ham operators, and we use it in our high-altitude balloon, the weather balloon experiment, where we use it to track the balloon when it's flying in the air. And we were like, why couldn't we use this to track cadets? And so I actually wrote to Bob, and I was like, hey, can you give me a contact at Kenwood? Because the radio one of the best ones is the one that he actually helped design at Kenwood. Compared to the satellite system, I think it's going to be a lot cheaper. But one of the things that happened, once the cadets got over this one ridge line, they lost contact with them. And so that's where satellite, works well. So this is all line of sight on the ground. But the advantage with the system is it's built to have what's called a digipeater. So as long as you have enough digipeaters in the area that can give the coverage, it's kind of like a cell phone tower in a sense, where it's able to receive the signal and then retransmit it to either another digipeater or iGated, or it's going to go to wherever you need it to go, so you can build your map. And they tested it out, and sure enough, it turned out one of their digipeaters wasn't working properly. They fixed it, and then they were able to track the cadets. So it looked like it was a successful experiment. So, and again, it's like I said, it's not all about HF. That's a VHF system, but you just got to understand, what are you trying to do? In their case, they're just sending a GPS location. Well, 1,200 baud, it's a pretty low data rate, but if you have a digipeater set up in the right locations on the right hilltops, you're able to have the system that doesn't rely on satellite, and you're able to do exactly the same thing.
Thank you again, Colonel Hamilton, for coming out this morning. Really appreciate your time.
Yeah, sure. No problem. Thank you.
Next time on Think Tank.
Well, maybe it's a guiding principle. We should follow sovereignty, as often as possible, but we're not going to be able to follow it all the time. Maybe there's good reasons to pierce the veil of sovereignty.
Thank you for joining us.